Hello. Hi. I started doing embedded systems development about 12 years ago, and then I started doing Python development about 10 years ago. And about 6 years ago, I thought two great tastes that taste great together, right? So we're going to find out how well Python and embedded development and cross-compiling mix. So what will we be covering? I want to say outright that we're not going to be covering porting Python to another OS. That's a longer talk and very specific to whatever OS you're going to be porting to. And it turns out that compiling is pretty useful because it's a prerequisite to porting to another OS. And there are a bunch of OSs that are used for embedded systems that Python already has support for, and so we can just do compiling. And this talk will focus on compiling from Linux x86 or x64 to PowerPC or an ARM or a MIPS target. And today's examples are going to be entirely on ARM. So the other good thing about Python and embedded development at the moment is that it's easier than ever to get involved with doing embedded devices because there's a whole bunch of devices that are under $200 that have Linux on them, and most of them already come with Python on them, so you can get going right away. So here's some example devices, and other than the Raspberry Pi, all of these run the Angstrom Open Embedded distribution. And my understanding is that people are working on getting the Angstrom Open Embedded distribution on Raspberry Pi. And the Angstrom distribution takes care of a build system for you if you want to do cross-compiling of Python and extensions. So if we already can get this basically for free, why do we care about cross-compiling Python and extensions? Well, last time I checked, Open Embedded only had version 2.7 support in their tree, so if you're a Python 3 enthusiast, then you are out of luck. Maybe they don't have the third-party extension that you want to be compiled, and maybe in the course of what you're doing, you want to write your own custom C extension, and that won't be included in the Angstrom distribution because you've written it. Or perhaps you have some requirement that says that you can't use the Angstrom distribution because you're adding it to an existing system. Or perhaps you're targeting another OS other than Linux. So let's assume that you've been convinced that you need to do the compiling yourself, and you have a little bit of experience with cross-compiling stuff. So you figure Python has a configure script, and configure knows how to deal with cross-compiling. We're all set to go, right? We can just run the configure script and pass all the right arguments to it, maybe override some compiler things, and everything's going to work. And you know, maybe you get as far as getting the configure script to run, and maybe you get partway through the build, and then everything explodes, and you realize that Python and its build system knows nothing about cross-compiling. So don't worry. All you got to do is this, which looks really scary, and I don't actually expect you all to read and understand this right now. But, you know, it's not that bad. All you're doing is building Python for your host system. Okay, so your host system is the system you're doing the compile on. And you need to take a copy of parser of Python and your parser pgen, which is used during the Python compile step. Then you need to clean your build directory So you're starting from scratch, and then Python needs a patch to tell the build system about a little bit about cross-compiling. Then you run your configure again while telling it about your target machine. And then you run make while telling it about your target machine. And then you run make install while telling it about your target machine. Oh, and because you're not really going to install it in the place that is the final location on your embedded system, you also have to override prefix. So, what was all that while telling Python about the cross-compiling? Well, Python doesn't know about cross-compiling, so we have to keep reminding it. So what could possibly go wrong with this? Well, there's a lot of things you have to do manually. You have to have the correct patch for your version of Python. Every version of Python manages to break the previous version's patch in weird and interesting ways. When I went to compile Python 3.3 Alpha 1, I found that the patch for 3.2, it patched cleanly, except part of the build process added an extra thing that required knowing about the difference between the Python we're building for the target and the Python we're building for the host. Missing include and library search paths. You have to manually point includes using C flags. You can't even tell it with an argument that says, hey, you know, this is the paths we need to use. No, you have to use C flags with dash I's that get parsed out by the build system to know that you need to add those search directories to the include and library search paths. And of course, if you're targeting an embedded system, maybe your build target, you haven't built your C dependencies yet. So if for some reason you have a problem where you're missing some includes or library paths, or perhaps you're missing a C dependency, you'll get something like this, which is actually pretty helpful because it tells you exactly what it can't find. But it doesn't tell you whether it can't find it because you don't have that dependency, or you actually need to set the include paths correct. All right, so now we have a Python, and that's all well and good. We've got it running on our device, but there's some third-party C extension that you want to run. And you know, I don't know, something like pill or what, I don't know, there's lots of compiled extensions you might want to use. So then all we need to do is that. And so the first 3/4 of that slide is solely setting up the build environment, and we've actually chopped off some of this stuff because we had extra flags from the previous slide are sort of passing through to here, so we could make this slide a little longer. But the last 3 commands there are the main things. So once we have our build environment set up, you just call the Python on your host, which you installed somewhere, you know, back in the install stage, so that you would have it to run when you needed to do cross-compiled extensions. And we're splitting up 2 steps here, the build and the Beatest Egg, in part because we want to get rid of any extra information from the Beatest Egg and focus just on the build. So you might notice from that Python doesn't know about cross-compiling, and neither does DisDetails, setup tools, distribute, or the library you're building. So this can add some other things that could possibly go wrong. Some of these should look familiar from building Python itself, except That include and library search path, well, if you didn't install your Python on your target to a location in the regular tree, you'll have to worry about that for your include. So you have to add an extra include for your Python. Many modules do hard-coded search locations for libraries. So you may have to go and edit the setup.py file for the particular library that you're using in order to get it to find the C library that it's using. And so that might masquerade as a missing C dependency, or you might have a combination of missing the hard-coded search locations and a missing C dependency. And then there are some fun and exciting packages that choose to use auto tools to do their build step instead of DisDetails. So they add another level of complexity. And they use configure make and this script that probably none of you have heard of called Python config that gives you all of the build information for how to build a Python extension module. It's very similar if you've done any like GTK or glib building. There's a config that gives you all the information about where the stuff is installed and that sort of thing. And two notable exceptions for that are PyGObject, OmniOrbPy, dbus is another example. They seem to be kind of system-y kind of libraries that want to do that. And then the last line of this thing here, there's a move command, and that's to do with the Beatest Egg. So if you're not familiar with what Beatest Egg does, it creates an egg distribution. And in this case, we're creating a binary egg distribution because we have something that's compiled, except that it gets the platform for the name of the binary egg distribution from the host Python. So we need to fix up the name of that in order to be able to have that be recognized on the board if you're trying to use easy install to install that egg. So this error is a sure sign that you're not properly setting the include for your target Python. And what's happening here is I was building on x64 and my ARM target is 32 bits. So the long bit definition appears to be wrong. Well, yeah, because the host is 64-bit and the target is 32-bit. So you just need to make sure that you have your target Python directory set up properly in your includes. So once you actually have your software cross-compiled for Python, you're going to be heading over into doing some stuff on the target. And you may be interested in using virtualenv to separate out dependencies in case you're running multiple things that have conflicting dependencies. And you may be tempted to use pip to have all of your requirements. The problem with pip is it insists on trying to compile everything that it installs. So unfortunately, to get that platform-specific egg that you built onto your board, you'll have to use easy install to get it into your virtualenv. There are other ways that you can deal with your distribution, but that's, again, a different talk. Now, there are other platforms you could be going for instead of Linux. Android, yes, I know it's Linux, but there's some weirdo things about Android as well. And so there's a project I found where they give you a cross-compile environment for Android, and the link to that is in the slides, and the slides will be available online later. And I also found some people that were having some success with cross-compiling Python for iPhone. And they were doing it from Macs directly to cross-compiling for iPhone. And both of these are basically, these projects are wrapping up the techniques that I showed earlier on with the patching. So they include a patch for a specific version of Python that they want to target, and they apply the patch and run the Python build multiple times. So we've got a Python built for our embedded targets, and where do we go from here? Because that was maybe easier than some people expected, but it's also harder than it should be. It's pretty obfuscated to have to build Python and then clean your build and then patch and then build again. I mean, there's no direct path to that. And a lot of people are saying that mobile is the future of computing, and I don't know if that's true or not. It sure looks like it is. It sure looks like Apple and Microsoft think that that's the way it's going to be. So if that's the case, then cross-compiling is going to become pretty normal. And if cross-compiling becomes normal, then I think Python should have a story for how we're going to support mobile. So, and if I don't know what that story is going to be, but I think that the Python community should have a method, probably in the core, that handles this, including having, say, DisDetails knowing about cross-compiling, because if you're building for a POSIX target on a Windows host, say, you're really in trouble, because Python, the DisDetails, takes information out of the running environment to find out what it's trying to build for. So, in prep for this talk, I have one of those boards that I talked about on the first slide, and I've put it into a little Lego case here, but we're attached. So we should be able to see that we are running on ARM, yes, and I have a Python going. So this is the 3.3 alpha 1, so let's try out, we have U prefixes, yay, and I'm going to import markup safe. So I'm also a web guy, so when I think of things that I want to put on an embedded system, I think about web things, and markup safe is a web thing. And part of markup safe is an optional speed up class. So if we do we have a compiled module for the speed ups class in there. So that's so we're able to get stuff going there, and I don't know, I guess I ran a little fast there, and we've got lots of time for questions, so if you have questions, there's microphones.
Yeah. Can you?
Hello. There we go.
Yeah.
So what is it going to take to actually get the build system and DisTilts in the source code out there to support cross-compiling? Because this, while it's doable, it's kind of madness.
Yeah. The worst part about the build, and the thing that means that we have to keep telling the Python build system about cross-compiling, is DisDetails. And DisDetails makes, as I said, makes decisions about how it's going to build, what it's going to build, based on the host Python. So I did some experiments at one point with a DisDetails extension that monkey patched DisDetails at runtime to fix that, but I think that that's a pretty hacky solution, but perhaps the things that were altered in that instance are things that we need to look at having some configurability and some knowledge about in the build system itself. So one of the things that DisDetails does to figure out what is happening is it parses the original makefile from the Python build to get all of the C flags and the compiler and all of that sort of thing. So if DisDetails knew that maybe you needed to be redirected to another install location to get that information, then that might go a long way in terms of at least the module compiling.
So speaking about DisTilts, why do you even want to use DisTilts?
Why do I want to use DisDetails? Why don't I want to use DisDetails?
Well, I mean, DisTilts, what it does, it takes, it calls just your compiler with the right options and stuff, but it's not hard to write a simple script that does that as well, and then you avoid all these problems.
Sure, except that the module that you're installing has already defined what all of the things that it needs are in order to build. All the source files, all of that sort of thing. And that's all driven through DisDetails. So if you're taking it out of there, then you're going to have a brittle system. Because what happens when they add another C file and you want the new version? You have to go and edit your whatever you're doing to
well, I mean, you could just write a package which is like distribute, but a special version of distribute, which is for cross-compiling, and its setup function
sure
does it all,
right,
and avoids DisTilts completely.
Well, it doesn't, because DisTilts is an extension. Sorry, distribute is an extension of DisTilts. So just like I said about the extension that I had, the DisDetails extension that I had made, distribute is an extension of DisDetails, and it still uses DisDetails as the machinery to do most of its work.
But you could write your own distribute, call it distribute cross-compile, which does not build on top of DisDetails, and then you don't have to monkey patch anything.
But so I don't know if you've looked at the source for DisDetails, but there's a lot going on there. So it sounds like a nice and simple suggestion to say, well, we'll just do whatever DisDetails does and we'll do it differently. But there's a lot going on in DisDetails, and people do. One of the things about DisDetails is people can add extra extensions to it. So for instance, if you have an extension module that's running swig, then there's a hook in DisDetails to recognize swig and do the pre-build step that converts it into C code and add it to the list of sources to be built, or Python. So there's a lot going on in DisDetails that is, as an end user, you may not see what's going on. I'd be hesitant to throw DisDetails out completely. I would much rather try and work with the core developers to get cross-compiling support directly in DisDetails. I think that's an easier path, but I think it's a path that hasn't been gone down because the cross-compile embedded community who are using Python, we've been able to muddle through. And it's when you've got something where you've managed to muddle through, it's a lot harder to then say, okay, well, I've managed to muddle through. Now let's go and interface with Python core and try and get this through. I mean, that's...
Well, I mean, it would be a lot easier. It would be a lot easier if you had your own cross-compile build system, because then you could iterate much faster and you wouldn't have to wait for new Python releases to get it in DisTilts.
Sure. Personally, I think I'd rather make embedded compiling be a killer feature of Python 3. I think I'd rather work with core and get the support, including the support of building Python itself, because you still have that step of getting Python compiled and installed before you're even talking about third-party modules. And DisDetails is the core of how the compiled modules in Python core get built. So even though we're running make, behind the scenes the make file is running DisDetails, a very, very big setup.py file.
Yeah. Thank you.
Do you have any plans to package your BeagleBone distribution of compiled Python for others to just pull instead of having to build themselves?
Yeah, I can do that.
That will be lovely.
Yeah, it's what I have right now is 3.3 alpha 1, but and I will put up on GitHub for sure the patch that against 3.3, because there was a change between 3.2 and 3.3.
This is probably totally out of left field, but I'm just curious if you've looked at PyPy and cross-compiling PyPy.
I have looked at compiling PyPy, and it brought my computer to its knees.
It was the compile of PyPy that brought it to its knees?
I should have known that after David's talk this morning that I was going to be asked this. I think I share some of David's sentiments from this morning that you know, I don't know enough about PyPy to know whether I can tinker around with it. So they're doing some very magical things to get from source to C, and part of their build system, as far as I'm aware, it generates different C source code depending on the platform you're on. So it might work if you, I don't know, it does a lot of introspection about like the AutoTools style thing about the environment you're building for. So you'd have to, I have no idea.
Yeah. Thanks.
Any more questions, or we're out of time, or?
I think that we are out of time. If you have any questions, please ask him. Feel free to get him in the conference and dig a lot in this interesting topic.
Yeah, I'm generally running around wearing a funny hat like that guy, and if anybody wants to talk about this or wants to come and sit down with me with the BeagleBone and do some hacking, that's great, and maybe we can set up an open space or something. But thanks.